ASK, you know everyone that the change in amplitude makes the difference in a signal when you are sending in a digital bits to analog bits. But what happens in the frequency shift key? That means if you have a binary bit 1010, at that particular point at a 1 you have the higher frequency. But when it comes to a 0 you have the lowest frequency, and when again it comes to 1 you have the highest frequency. And again the 0, the lowest frequency you have it. That means you have the two kind of frequency. That is a frequency 1. Here listen, the amplitude remains the constant, there is no change in the amplitude. And the frequency f2, that is nothing but a frequency which have the lowest frequency. So we are using the two types of frequency f1 and f2. If you look at the bandwidth in ASK, that is equal to S into 1 plus D. Now D depends upon the filtering and the modulation process. So that will be defined in the question itself. If it is not defined, put it as a 2, 1. The value of D as a 1. So here S stands for a sampling, or we call as a bound rate. You know everyone what you mean by the bound rate and what is the difference between the bit rate and the bound rate. So S stands for the bound rate. And this is what the equation for an ASK. But in FSK is somewhat different. What is the reason to have somewhat different is we have a two different frequency in FSK block. So what should be the equation should I write for a FSK? So I must have the two frequency F1 and F2. So here the F1 stands for first FC plus K of M of t. Now here this M of t represents the message signal, what you are sending in a binary bits. And I have the another term we call as KF. You know about the frequency, that is a carrier frequency we always add with a constant amplitude and constant frequency. So how many constant terms we have? Carrier frequency is constant, the message what you are sending, that is also constant. So for what the KF stands for over here? The KF is nothing but a simple. If you want to increase the frequency of a carrier, I'm going to change my KF, that is nothing but a kilohertz in terms of kilohertz. So you are adding something in a carrier frequency, it will increase the frequency. Where the F2 is nothing but a carrier frequency minus KF into M of t. Now which are the constant terms? M of t is a constant, carrier frequency is a constant. So if I want to decrease my frequency, I need to subtract some frequency from my carrier frequency such that it have a lowest frequency instead of highest frequency. So F1 that will be equal to Fc plus K of M of t, and F2 that will be equal to Fc minus K of M of t. Now here for the F1 is what? The Kf and M of t you can consider as a delta F. Okay. So you look at over here. For the each one bit, you have the highest frequency, then the lowest frequency, then the highest frequency and the lowest frequency. Look at this. The highest frequency we call as a F1, the lowest frequency we call as a F2. For the logic 1, we are getting the highest frequency. For the logic 0, we are getting the lowest frequency. So what should be the bandwidth over here? And what is the 2 delta F stands for? So here, bandwidth of a FSK, that will be 1 plus D into S plus F1 minus F2. When you do it with F1 and F2, what is the equation of F1? Is the FC plus K of M of t, and the value of value of f2, that will be equal to fc minus k of m of t. When you subtract the f1 minus f2, what actually you are going to get is nothing but which component will be cancelled out? When you do with the f1 minus f2,
FC.
fc will cancel out, so remaining is nothing but a 2 k of m of t. So plus and minus minus plus. So 2 times k of m of t. So here's the delta f. 2 into delta f if you compare. So delta f is nothing but a k of m of t. Is things clear? So your bandwidth of FSK, that will be equal to bandwidth equal to 1 plus d into s, that is a bound rate, plus 2 times delta f. Delta f stands for k of m of t. Okay, find out this equation. What should be the carrier frequency? I need the value of a carrier frequency. Find out the value of carrier frequency. What should be the answer? Write down in the chat box, all of you. Okay, 25 kbps Rusty. What about the rest students? I'm still waiting for the answer from rest of the students. There should be 14, 12 replies would be there in your chat box. Yes, Harsh, Anurag, Ayush. Am I audible, all of you? Anurag?
Yes, sir.
Anurag, not there? Okay, join again.
Yes, sir. Yes, sir. Yes, sir. Yes, sir.
The, the answer. Ayush,
Yes, sir.
answer. Harsh, still not
Yes,
there?
sir.
Okay, write down the answer for the given question. Harsh Moda, Harsh Moda. Okay, join again. Mihir,
Yes, sir.
what is the answer for the given question? Mukund,
Yes, sir.
need answer. Nasib,
Yes, sir.
What is the answer for the given question? Sanskar,
Yes, sir.
Santosh,
Yes, sir.
Shruti. Write down all of you the answer. And I'll take the attendance. I want to know that how many students are present in the class. I need sampling frequency or a bound rate. Just is a bits per second or a bound per second? Bits per second, okay. What are the rest of the students are doing? Yes, Ars, what is the bandwidth of a FSK? Ayush and Ars, give me the answer for that. Just we had completed 5 minutes before. What should be the bandwidth of ASK and what should be the bandwidth of FSK? Ars, if you cannot able to give answer, so let it be, okay. If the connectivity is a problem, you can join it again.
No, sir, no, sir.
What about Ayush? Still, if you don't want to give answer, no need to attend the lab session. Okay, you can leave. Ayush still cannot able to hear me.
No, sir, I can hear you.
Then what is the answer? What I had asked, something I had asked you. What is the bandwidth of ASK and FSK? Write it down in the chat box. Need answer from the Ayush Jagani and Harsh both. Rest of the students solve the problems and write the answer. Till that I am not going to go to the next slide. FSK bandwidth, I didn't ask the FSK bandwidth, I asked you the equation of the FSK. What do you mean by delta F Harsh over there?
Sir, final frequency minus initial.
Islands frequency minus initial?
मतलब जो सेकंड दो फ्रीक्वेंसी होते हैं उन दोनों का माइनस मतलब
Then what
डिफरेंस
is the remaining term which we'll get?
F1 minus F2 डेल्टा F मतलब
Does anyone knows? Rusty, what should be the delta F?
F1 minus F2 sir.
Wrong. Rusty?
So 2 times of kf.
2 times of kf into m of t.
M of
That
t.
is a message signal. Now Hers had already wrote the answer over here, the bandwidth of FSK. Now, based on bandwidth, just find out the terms I required in the question, all of you. Now I need the answer from each and every student. Hundred kilowatts.
Sorry, sir. 50 kilowatts. Sorry, sir.
यदि सॉरी सर કરીને 25 લખી નાખ કિલોવોટ્સમાં આવે વેલ્યू
Yes, sir. 50 kilowatts.
25 kbps. Very simple questions. All the things had been given over there. The Rusty Road, that is the correct answer. Look at the problem statement. Solution is in front of you. Okay, now you know about this FSK signal. Now we don't have a comparator over here. Instead of that, we have VCO. Now the VCO stands for is a voltage control oscillator. Now, what do you mean by the voltage control oscillator over here? According to digital signals have only two voltages. For the logic 1, it should be a 5 volt, and for the logic 0, it will be a 0 volt. Now, based upon that voltage, it controls the oscillation. Here you require the large oscillation, here you require the less oscillations. That means we need to control our oscillation based on the input voltage. That's why we always have a VCO, where the input signal is a digital signal. The VCO have the two inputs, one the digital signal, another is a oscillation signals. So it controls according to the voltage, it controls the oscillation, and this is the output of the VCO that will be in the analog form, and that is what we call the voltage control oscillators. You don't have to go deeper in the circuit, what is the VCO made up of and everything. Just understand the voltage control oscillator is a simple concept. Now we'll go to the multisim circuit. You don't have to do anything, just listen and observe the things what I am telling. After that, you will tell delta F is nothing but a difference in the frequency of F1 and F2. That is the wrong answer. Can able to see the multisim circuit?
No, sir.
Yes,
No,
sir.
sir.
Sir, no, sir.
No, sir.
It's taking too much of time. Now the screen is visible.
Yes, sir.
Okay.
Yes, sir.
Yes.
Okay.
Yes, sir.
Now all of you just tell me what are the applications of a transistor? What are the applications of a transistor? What is the application of a transistor? Search in the internet and tell me the answer. The application of a transistors. There should only be two applications there for which we use the multiplier. Find out in the internet and tell me the answer. And write down in the chat box. All of you have the internet with you, correct? Only two students have the facility of internet or what? Mukund and Sanskar. Okay. So all of you agreed that okay, transistor can work as a switch. Does anyone tell me that how many terminal does the transistor have? You already studied in the BEE.
Sir, three.
Three
Which are
terminal.
they?
Oh,
Which are they?
Sir, emitter, collector, and
or base.
base.
Emitter collector base.
Okay. Now look at in the circuit. Which terminal is a emitter, which terminal is a collector, and which is the base? Where I applied the input? Which terminal is this? You said that is correct. Base, collector, and
Sir,
emitter.
this is a NPN transistor.
That's okay. I didn't ask you it's NPN or PNP. I'd asked you
Sir,
that
but
which is the emitter.
एमीटर साथ जहाँ करंट जा रहा है, जहाँ पे एरो है वो एमीटर है.
Okay, arrow है वो emitter है. Now,
हाँ,
what is the terminal at Q1?
कलेक्टर.
Okay, that means that you had applied the input as a base, correct?
यस सर.
Okay. Now, if I want to work as a transistor as a switch, then it should be input should be in the form of digital or analog. If I want to use a transistor as a switch, whether the input at the base should be analog or digital.
सर डिजिटल.
Digital. If you are using your switch, they have two values. Either you on the switch or off the switch. Now, if your transistor is on, then and only then the current from a collector will go to the emitter and complete the path of a VCC to ground. If the transistor is an off state, no current from a VCC can go to the ground because the path is incomplete. It's an open circuit. I think it's
Sir,
clear
your
or not?
screen is not visible
Screen
for me. It's not visible.
for others is visible, and here I can see that anyone can able to see the screen.
But
Is it correct,
it's
Anurag?
there for me.
Yes,
यस
sir.
सर. यस
I
सर.
just leave and again join. Okay, Anurag? Ayush Jagani?
Yes, okay.
Okay, so I have the transistor. Now, look at the function generator. What is the input I had applied for a function generator 1? Which signal I had applied? Sine wave, triangular wave, or a digital signal? Does I applied sine wave, triangular wave, or a square wave?
Sir, triangular.
Look at in a
Okay, for first.
function generator. First is a sine wave. Okay, now visible. Now I zoomed for you.
Yes, sir. Now it's
Yeah.
visible.
Okay, which is the signal I had applied? Sine wave, triangular wave, or a digital signal? Circuit is in front of you. Then also,
सर मतलब आपने वो फंक्शन जनरेट को बड़ा किया है.
हाँ
सर वो
आपको
दिखाई
दिखाने
नहीं
के
दे
लिए.
दिखाई नहीं दे
वो
रहा.
हमारा सर्किट ही आपने पहले ड्रॉ किया था ना, वही है सर.
ओके ठीक है, लेकिन अभी फंक्शन जनरेटर तो दिख रहा है ना आप लोगों को. आई जस्ट ओपन द वैल्यू ऑफ एन फंक्शन जनरेटर. उसमें मैंने डिजिटल सिग्नल दिया है. ओके, द फंक्शन जनरेटर 1. At a function generator 2, I had applied a 500 kilohertz of sinusoidal waveform. Now that input is going on a collector region. This is your carrier frequency, function generator 2. That is your carrier frequency had been applied. So when the transistor gets on, the carrier frequency from collector to emitter, it will go. But when your transistor is off, none of the carrier frequency will go to the transistor from collector to emitter. Okay, so now let us run the circuit at this oscilloscope. I want to look at the output. One input, the red color, that is the output I am finding from a, what do you call, this transistor output. And the one another input I took from a carrier, and the third output I took it from a digital signal. Now let us just open this. See, look at over here. This pink color is a input you had applied channel 3, and channel 3 is of digital signal. So this is digital signal, the pink color. The blue color, that is nothing but a carrier frequency. When you multiply this to both, you will get whenever you
Sir,
have the
oscilloscope is not visible.
oscilloscope visible નથી.
ના sir.
એક મિનિટ ઉભો રહે. So we ready?
હા sir.
Yes, sir.
Yes, sir.
Yes, sir.
Now look at the oscilloscope. So the pink color, what you are looking, that is a digital signal which you had applied to the transistor. Here, this channel 2 is nothing but your carrier signals, what you had applied to the collector. So when the transistor gets on, it multiplies with the carrier and you will get your output. Same. But at the logic 0, you won't get anything, none of the carrier, because your transistor is off state. Your carrier frequency from the collector will not able to pass it from the collector to emitter. Okay, think it's clear all of you?
Sir, blue वाली है वो carrier है ना?
हाँ, blue वाली वो carrier है.
Okay,
And
sir.
this pink color indicates the logic 1 and logic 0 to the transistor. Okay. Now, this is what about ASK? That with the circuit what we had done for the ASK. What happens in the PSK? Oh, sorry, FSK. So what I took over here, the multiplexer I had took. Look at the circuit. This is a multiplexer. One of the input on a multiplexer, I had given a frequency of 100 Hertz. Another function generator had applied 500 Hertz. Why? What is the reason? Both are sine waves. Why the sine wave? And why the multiplexer? Why the sine wave at two different function generator and why the multiplexer?
सर फ्रीक्वेंसी के लिए शिफ्टिंग की है, इसलिए दो एनालॉग सिग्नल लिए.
हाँ, दो frequency इसीलिए चाहिए because for the logic 1 we required higher frequency, for the logic 0 we required lower frequency. Correct? For that I took the two different frequency. And why the multiplexer had been applied? First, all of you, anyone knows what is the job of a multiplexer?
सर बहुत सारे सिग्नल को एक में कन्वर्ट करता है.
Okay, that means if what are the inputs are required at the output, that I can able to do using multiplexer, correct? If I have 8 inputs and which input I need to put it on a line at the output, I can able to select any one of the inputs. That is the job of a multiplexer. So I'd apply the two inputs, D0 and D1. What the A stands for over here? Look at the function generator 3. There I had applied digital signal. Why? First of all, just tell me it's a 2:1 mux or a 4:1 mux? Is it 2:1 mux or a 4:1 mux?
सर 2:1.
2:1 mux. Okay. So if it is, if I from this selection line, if it is 0, D0 will go to the output, and if it is 1, D1 will go to the output. Are you agree? D0, and if the selection line is 0, D0 will go to the output, and the selection line is 1, D1 will go to the output. And if you look at the A, I had applied a function generator, that is the digital signal I had applied. Why I had applied the digital signal?
सर दो इनपुट है 0 और 1, इसलिए मतलब.
That's why. Now that is what the selection line. If you add a 0 or 1, based on that your frequency is going to your output side. That's why at the function generator 3 I had applied digital signal. For this 2 I had applied analog signal. Now when you open the 4 channel oscilloscope, in the first channel that is the output of a multiplexer, in second channel the output of a function generator 3, that is a selection line. So when I run this, let's have, this is what the output I required actually. For the logic 1, highest frequency, for the logic 0, lowest frequency. Yes, this is the output I required. Is the output is correct? Yes, the output is correct.
सर उसमें तो जीरो पे भी आधा वन होता है इसमें
No,
तो
it's fine. You can do it anyway. If you want like that, okay. What you need to do, instead of 100, do it 500. Here, do it 100. Okay. Again. Now, just I'd inverted. That doesn't mean that. But this is the output I required. Actually, that is my question is. Do we think that this is the output of a FSK I required? Okay. We'll take a break of a 10 minutes. Till that, you just decide by yourself that this is not the correct answer. I am telling that. This is what not I want. Or in the FSK circuit we want. We need some different thing. And why these things are getting as output, that is what you have to look it for. Okay, do you need a break? Do you need a break?
सर आंसर फाइंड करने के लिए चाहिए
That's what. Okay, we'll take a break and find out the answer. Then we'll meet after 10 minutes. So we'll meet at 1 o'clock sharp. Till that, just you think about the answer and what are the changes I need to do. That's all. I need 2 answers only. Just wait a minute. Should I open the circuit for you? So this is what the circuit and this is what the output you are getting. I don't want this output. I'm looking for some different output. This is what the output we are getting, but we are looking for a different output. Did anyone get the answer? Okay,
सर
let us.
मतलब कि ये डिजिटल वाला।
हाँ हाँ, बताओ बताओ।
हाँ सर, उसमें मतलब हमें डिजिटल आउटपुट नहीं चाहिए, हमें एनालॉग में चाहिए आंसर।
किसने आंसर दिया? ये मुकुंद। गुड. So how will get and why we are getting the digital output? That is what my question is. Why? We need
सर
analog
क्योंकि
output.
हम दो एनालॉग सिग्नल को मल्टीप्लेक्सर में डाल रहे हैं तो उसका हमें डिजिटल मिल रहा है।
Why? That is what I'm telling. Why?
क्योंकि
ऐसा क्यों हो रहा है?
सर मल्टीप्लेक्सर डिजिटल के लिए यूज होता है ना।
वाह, good. अनुराग, पनवा.
Yes, sir.
Okay, आयुष. કોઈ સુવા જતું નથી રહ્યું ને?
Yes,
That's
sir.
what I'm checking. Okay. દ્રષ્ટિ,
Yes, sir.
હર્ષ, મોઢા,
Yes,
મહેશ્વરી
sir.
બને. મોઢા, હર્ષ. જમવા ગયો લાગે છે. હર્ષ મોઢા. ઓકે. માધવી. ઓકે. મહિર,
Yes, sir.
સંસ્કાર,
Yes,
સંતોષ,
sir.
શ્રુતિ, સંતોષ, હર્ષ મોઢા.
સર ફેલ ટુ સેન્ડ આવે છે.
ફેલ ટુ સેન્ડ ક્યાં? તને બોલવાનું કહું છું. અત્યારે કેમ બોલ્યો? એ રીતે પહેલા જ બોલવાનું હોય.
ઓકે સર, સોરી સર.
Okay, so Mukund had given the correct answer that the multiplexer is nothing but a digital signal. So you cannot able to get a analog output, though you are applying analog input, but that input will not go to the output. The reason is multiplexer. Okay, so what we are doing, I'm just sharing a one circuit with you. Okay, hope screen is visible, all of you. Okay.
Yes sir.
So this circuit is
Yes,
wrong.
sir.
We are not getting બસ 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 બે જણા કહે તો ખબર પડી જાય કે બધાને દેખાતી હોય. એટેન્ડન્સ બોલવાનું કહે ત્યારે બધા ફટાફટ બોલતા નથી. Okay, the multi-sim circuit, what we had implement this for FSK is wrong. We are not able to do this. So we'll go with this diagram. Understand nicely this diagram because we are going to implement this in a multi-sim to make you understand about the FSK signal. So you know about this thing. Let's suppose if I have the digital signal like this, and the carrier frequency that will be highest for this, again the lowest for this, highest for this, lowest for this, highest for this. So for the 0 it is the lowest, for 1 it is the highest. So let's suppose here I have the input. This is what the input I have, and I'll multiply the highest frequency of a carrier signal to this, and I have over here that is inverted of this. So inverted, that means here the logic 1, it should be the logic 0, here the logic 0, here the logic 1, again the logic 0, and with this I will multiply a lowest frequency. With this I'm doing multiplication with the highest carrier frequency, the digital data with the lowest carrier frequency. Now this multiplier will multiply two things, a digital data and an oscillator. Now in this digital data and oscillator F1, what exactly we have? Digital input with the highest frequency F1. When they multiply together, what is the output we will get? I'll get this output. For the logic 1 and logic 1, you will get your carrier frequency with the highest frequency. For the logic 0, you won't get anything. Now, what happens over here? This is inverted. That means what should be this value, now it will be this value. Multiply this value with the lowest frequency f2. What is the output you will get? You will get this output. See here, at the logic 1 you have 2 period of cycle. Here for the logic 1 we have 1 period of cycle. When you combine these two signal together, what exactly you are getting? Highest frequency and inserted lowest frequency. Is the thing is clear? Diagram?
Yes, sir.
Still you have doubt, you can ask me any questions in this diagram so that we can directly go to the circuit in a multisim.
सर वो जो हाईएस्ट फ्रीक्वेंसी वाला है ना, जो वन आउटपुट के लिए, उसमें जैसे कि 2 साइकिल है और इसमें
हाँ।
उसका मतलब एक ही आया, तो ऐसा हर बार ऐसा ही होता है कि
इस
2 का एक
बार
ही आएगा?
तो हर बार ऐसा ही होगा because you look at over here. We need for 1 you required highest frequency, for the logic 0 you required lowest frequency, again for 1 and again for 0, but frequency remains constant.
नहीं सर, मतलब जैसे कि इसमें 2 साइकिल के लिए हमें 1 मिला, ऐसा हो सकता है कि अगर 3 साइकिल होगी एक
Now
इनपुट के लिए
just
तो
increase
1।
yeah, you can increase the frequency from f1 and f2. How much cycles you required, you can use increase or decrease the f1 frequency. Clear?
यस सर।
Okay. Now this is what the circuit we are going to implement. This signal is a data square wave, that is a digital signal what I need to apply. And look at over here. When it is go over here, this is the inverted input I had applied to the input 2. So this is the input 1, inverted, applied to the invert 2. In the S1, I need to apply the highest frequency F1. So it multiplies this 2. F digital signal and this 2. Again the frequency F2 that is given as the S2 and it multiplies with a input 2, that is the inverted input. And finally we are sorting these two things together such that it will work as a summation. So D1 and D2 will be added and you will get an output. This thing is clear, all of you? Okay, now your job is to find, everything is known to you. One thing is unknown to you, that is a 4066 BD. That is a IC. You have to find in the internet for 5 minutes, or you take 10 minutes, that for what this circuit is used for, 4066 BD, and write down your answer in a chat box. All of you. I need 12 replies in a chat box. Search that circuit and write down your answer in the chat box. Okay, good. Trusty 4066 is a quad bilateral switch. Okay. Okay. Quad bilateral switch. Okay. So now all of you, what you had searched, there is nothing that is correct. What you had searched is a quad bilateral switch. So there are the 4 inputs and 4 outputs. Sorry, 4 input and 4 outputs you have. It's a kind of a multiplier circuit. Okay. So I'm just presenting the screen of multisim. Is the screen is visible, all of you? Multisim.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So
Yes,
now
sir.
first thing I need to take as a that IC. Okay. So IC get it from all group. It's a 4066BD and put it over here. Okay, this is the IC. What I need to apply the input one, the function generator, digital input. Okay, so let it be. So here, just select the digital input, 1 kilowatts, let it be. So directly over here. What I need to apply the input to? What I have to apply the input to? What I need to apply the input to?
Sir, low frequency signal.
No, wrong.
मतलब सर पहले के इनपुट में
पहले के इनपुट में डिजिटल इनपुट दे दिया, अब दूसरे इनपुट में क्या देना है?
सर दूसरे में हायर फ्रीक्वेंसी
नहीं, फ्रीक्वेंसी तो अभी दी ही नहीं है, जस्ट आई हैड
मतलब वो कैरियर सिग्नल हायर फ्रीक्वेंसी वाला
नो. This one is nothing but a function generator. I applied input, digital input 1. What I need to apply input 2? Think and tell me the answer.
सर इन्वर्टेड सिग्नल
Yes, inverted signal. So I must require a one NOT gate. So that is a NOT gate. So I'll just put it over here. And then the input I'll apply to input 2 here. This circuit is available. Can you able to see the screen? This circuit.
यस सर
Okay. Now,
Yes, sir.
now the turn comes to apply a function generator. I must require the two function generator, 1 and 2. Let's suppose for this function generator I applied 50 hertz frequency, or I'll put it as 100 hertz, and for this I'll put it at 50 hertz. That is F1 and F2. So first frequency should multiply with this signal, and another frequency, that is lowest frequency, should multiply with this signal. Thing is clear, all of you? This thing is clear?
यस सर
Yes, sir.
Okay, now we can do it this all negative should connect to the ground. Okay, so I'll take a one ground. This is the ground signal. So this ground is connected to the multipliers. Now here, I need to fix amplitude. Okay. So here they take 10 volt peak to peak, but this IC, if I want to work this IC, I must require a peak to peak voltage on which the IC should work. I'll take as a VCC and I should connect over here. I'll give that an negative voltage because your analog signal goes from positive cycle to the negative cycle. So I'll take VEE, that is a negative voltage, and I will connect that over here. So this will be I am applying as a 15 volt. They are not connected actually. Oh, yeah. Now they are connected. Fine. So here it's a minus 15 volt, and these two output must be sorted. Why? What is the reason to sort these two output?
सर डिजिटल से एनालॉग में कन्वर्ट करना है ना, तो दोनों को
नहीं, दोनों को ऐड करना है. Okay, so we have a one oscilloscope. One of the input from oscilloscope I will look at. Okay, let us take the 4-channel oscilloscope. Four channel. At the first channel, I will take the input of this digital signal, and another channel I will take the input of this signal, and the third channel I will do the addition of both. Let us look what actually we are getting. So reverse, a single, so 10, and this voltage. Let us take the different values. So I will not take this inverted. It confused a little bit. Let's check 2-channel output only. So one output is a digital signal, another input is nothing but the combination of both. So this I'll take it as a blue color. It will make the sense. Okay. Now okay, now it is clear what actually we are doing. Look at this, where we have a high frequency and where somewhere we have a lowest frequency also. And this is what the
सर
output.
ऑसिलोस्कोप विजिबल
Oscilloscope visible nothing?
ना सर.
Okay.
Nothing, sir.
Wait. હવે now?
Yes, sir.
Yes
Okay.
sir.
So this is what the output we are looking for. So all of you, the clear about this thing? Any doubt in this practical what we had done for FSK? If you can able to zoom it this the time per division, this is the highest frequency for logic 1 and the lowest frequency for logic 0. Okay. So this is our nothing but we call as a FSK circuit, and it is very much clear about the circuit. I hope so. Is it clear, all of you?
Yes sir.
So still we have half an hour. What we are going to do then? how many are done about the Coursera?
સર વીક 3 સુધી થઈ ગયું.
વીક 3 સુધી બધાને થઈ ગયું?
Yes, sir.
हाँ सर.
અનુરાગ, આયુષ, દ્રષ્ટિ,
Yes sir.
Yes,
હર્ષ?
sir.
Yes sir.
ઓકે, ધ્યાન રાખજો. મંડે પછી માર્ક મૂકીશ ત્યારે પછી આ બધા યસ સર વાળા છે ને એ બધાને ફિલ્ટર આઉટ
Sir
કરીશ.
next
અનુરાગ પનવાર. હે?
next Monday week 3 સુધી check કરશો કે week 4 સુધી?
વીક 3 કીધું હતું ને મેં લાસ્ટ ટાઈમ. ના ના, વીક 4 કીધું હતું, સોરી.
Okay.
તો વીક 4 કેદી કરશો પૂરું? મંડે તો માર્ક મૂકીશું. વીક 3 સુધીના તો મુકાઈ ગયા માર્ક.
Sir, Monday લગીન થઈ જશે. Monday લગીન થઈ જશે.
ઓકે, તો ટિલ ધેટ આજે બધા what you can do, that is the website, you know about that ML education, what we had done, the chapter wise test we had given.
યસ સર.
Yes.
Okay, just open that and try to give the answer for chapter 3.
सर
Yes.
सर मल्टी सिम की सर्किट देखनी थी एक बार.
हाँ देखो. Okay.
Sir, can you post the link again in the chat box?
Wait. Education. Nah, I started with some. Okay, I'm just pasting the link over in the chat box. Try to view the exam for chapter 3. Anyone have a doubt can ask me. I had already given the link. Just go to the chapter 3 and just try to give the answer. Once you get the highest mark, you know the rules, what you need to do. Put your screenshot with you. Don't upload in the DCN, in a canvas.
સર આ કેનવાસમાં અપલોડ કરવાનું છે.
ના આ ન કરતા. સ્ક્રીનશોટ રાખજો તમારી જોડે, અપલોડ નહીં કરતા. ઓકે, વન્સ યુ ગેટ ધ હાઈએસ્ટ માર્ક જસ્ટ પુટ યોર સ્ક્રીનશોટ વિથ યુ. Madhvi Dalsania completed. Out of 34 questions, you answered 27 correctly. Okay, all of you just complete the today's task. Write down the attendance in a chat box. First computer, then IT. Only 4 students. નસીબ હવે જોઈન થયો તો કે હું?
सर फेल टू सेंड आ रहा है.
बोल.
90 CE 90.
Okay, all of you can leave. Those who wrote the attendance. I had given
सर
you the
मल्टी
task.
सिम सर्किट.
हाँ, देखो.
हाँ
All of you had given the task. Okay, so complete the task by today only.
ओके सर डन. क्योंकि सर जो आपने वो पहले सर्किट दिखाई थी उसमें बहुत सारे इनपुट्स हैं इसलिए
नहीं
ये
उसमें
थर्ड
ही
फोर्थ
है.
थे.
नहीं, थर्ड फोर्थ में जरूरत नहीं है, लेकिन डाल सकते हो. इफ यू वांट टू यूज इट यू कैन, अदरवाइज इट्स ओके, नो नीड.
मतलब उसमें क्या है कि कौन से इनपुट.
No, if you required, let's suppose 4 input आए, तो you can able to use 4 inputs. But till
Okay,
for FSK you require 2 inputs only, so no need for that.
ओके सर.
Okay. Okay, all of you can leave. I had given you the task, so complete the task by 2 o'clock and submit the quiz. It should be on my mail. Those only I'll give the attendance.